Let's talk about exponential equations. So we're talking about equations where we have variables in the exponents that we have to solve for. Okay. The easiest ones of these to do are the ones where there's only one x in there or one variable in there. It's not on both sides. But let me tell you this, because this you need to know before you can solve. And I hope you already recognize this. If I have 3 to the x equals 3 to the 5th, tell me what you know.
X equals 5.
X has to equal 5, right? There's no other thing that x can equal. So what if I change this then to 3 to the x plus 2 equals 3 to the 7?
7 equals x plus 2.
It's still x plus 2. I'm still, oh, my brain's getting ahead of my hand. Right? And then I could solve that. It's still the same thing, right? Mm-hmm. So the point that I'm getting at here is if your bases are the same.
We should have a quiz on this for you.
Yeah. So like
before it gets like really boring.
Then the exponents must also be the same. I'll give you. Let's kick it up just a little bit. Expand on this just a little bit. Let's say I had 3 to the x equals 81. What does x equal? Y.
4.
3 times 3 times 3 times. I guess that's 4.
What you're doing, but you're doing it in your head, is you're saying, what do I need that power to be? But you're changing the base here, okay? So you're changing it to a base of 3 and rewriting it, and now we can say that our exponent's equal, right? Okay, so we're manipulating that base. It's still got the same value. We're just writing it a different way so that we can solve for the variable. Does that make sense to you?
Yes, ma'am.
Okay. What if it suddenly looked like that? So my question to you would be, can you rewrite anything there to force them to have the same base?
Yes.
And it's got to have the same value. So on the left, the base still has to be 4. You can write it a different way, but it's still got to be 4. And the base on the right still has to be a half. You can write it a different way, but it's still got to be a half.
2 squared.
2 squared, Anna says. Okay, 2 squared. Now this x is still there. I've only changed the 4. How does that help me?
Because of the same base. Well, kind of.
Kind of the same base. Maybe I'm onto something.
Well, 1/2 and then an exponent.
How about if you did like 1/2 -2? It would feel good.
Okay, so it will. So you're saying, okay, and you're thinking along the right lines, but at the end of the day, it's still got to be a half. So take that same thought. What base can I use and what exponent where it's still a half? Think about it. Look at the base that you've got on the left.
Is there anything to make difference? You put 1 on top.
What'd you say? Close. Very close.
-4.
Negative
Oh,
1.
Ooh.
What is 2 to the -1 power?
1/2.
1/2. Does it still have the same value?
Yes.
Yes. Are the bases now the same? Yes. If the bases are the same, then guess what? I can set the exponents equal. So now I know that these are the same, and I can solve for x. So 2x must equal -1. Remember when we raise a power to a power, we multiply.
Alrighty. Wait, is tomorrow gonna be a review?
Yeah. Solve it for x. What do you do? I hear subtract. Come on, guys. Add the x. If 3x equals 3, what does x equal?
X equals 1.
Does that make sense to you? Mm-hmm. So what we're going to try to do is we try to rewrite, bless you, the exponential expressions with the same base, so that we can set, and I'm going to put in parentheses, that must be the same value. So while it would have been nice to write 1/2 as, I can't remember what y'all were saying to make the same base, 4 to the whatever, it's still got to be a half at the end of the day. Must be the same value. So exponents. And I'll give you all a second. Because you're supposed to change it, and I mean that's easy to recognize, but the hard part comes in finding out how you manipulating it, figuring out what that base needs to be so I can solve. So the directions simply say solve. Solve for x.
Can you square root it?
Nope. Well, what good is square rooting you going to do? I mean, you could, but what good is it going to do?
Make the square root over 27 divided by whatever it is to make it 9.
But how is that going to help you find x? Look where x is.
So you have to make the base of the same.
We get 3 to
Okay, so what are you going to do? Do 3 to the what, Anna? 3 to the third for which one?
for 9. Wait.
27.
I mean 27.
Yes.
Yeah.
All right, so we're going to change 27 to 3 to the third. The x minus 1 is still there.
9 3 squared.
And 9 to 3 squared. Bases are the same. The next exponent's supposed to be also. 2 times 2x must equal 3 times x minus 1. So on the left I have 4x, and on the right I have 3x minus 3. How do you manipulate that to solve for x? Minus 3x.
How did you get that 2 on the outside?
Which 2 on the outside?
3 and 2.
This one?
Down.
Down. Here?
No, the one on the
This one. Because whenever I manipulated this base, I changed it. It became 3 squared. So that 2 came from here. You take every bit of the exponent here and every bit of the exponent.
So you have to get the same base?
Correct.
Can we just keep doing these?
Think they're easy?
Yeah, they're easier than that last one.
Everything else is so freaking hard.
No, these are way hard. They're exactly.
I think we just need to go back to like 1 plus 1.
I think they're easy because she's
Start over.
helping us.
The more you tell her it's easy, the harder she's gonna make it.
Maybe.
Oh, I'm not.
It's the other way
Thanks.
around.
Yo, it's easy. Let's move on.
Thanks, it's the other way around.
Then we have to go like do some.
It actually, y'all are saying this is easy, and this is not a real easy concept, so that always worries me just a little bit.
Our brains aren't right.
Down.
Yep.
Pretty dumb.
Yep.
Never get.
I was good at math, but
No, you just hit the point where you have to try now. It doesn't, it's not so natural anymore. Everybody hits that course at some point.
It's like a sugar cube.
Let's do this one.
Dude, sugar cubes are cool.
Ooh, I better get a move on.
You just like go with your arm thing. Just like did your husband grow up in McGee Town?
My dad's family used to have a tobacco farm.
2 to the 5th.
2. I hear 2 to the 3rd. And 2 to the 5th. I'm going to set exponents equal.
Oh, I like this.
Do you? I'm glad.
I would say I like it.
It's better than.
You like it because you understand it. It's easy. Okay. Good. That's good. That's good. I'm kind of running through this because I'm assuming you guys have already done this. I gave
This is
some
not, I like
time.
doing that stuff, like this bottom part. This is fun.
All right, I'm going to add
It's the
10
only good thing I've done ever.
The same base is the orange
and
part.
move to 3.
And then the other part's not bad.
I got 7 over 12. Is that what y'all got?
Yeah.
Good. All right, then let's move forward.
Are we changing it?
I'm going to throw you a curveball.
Do we have homework tonight?
You have over every night, thanks.
We have it the past couple weeks.
Well,
Oh,
It's like a drive.
oh no, we're solving exponential and logarithmic equations.
oh my gosh, no.
No, stop. Look. Solve it. Oh, how? So what happens when I can't manipulate the bases?
Leave it.
But there's only one x. It doesn't look too bad, right? That looks like I should be able to do that. Any ideas?
4.5 plus 4.5 equals 11. Wait.
Can't manipulate.
5.5.
So you don't do anything.
What I'm gonna do, good try. What I'm gonna do is I'm gonna isolate my exponential piece. And in this case it is. You've kind of already solved some ones similar. When you get stuck with exponentials or logarithms, what do? Change the form. Change the form. Let's change the form and see what happens. What does it become? Log 4.
Why? That's freaking logs.
Now I've solved, because logs are exponents.
Oh, you're solid.
It's solved for you. So now all I have to do is take out my calculator and type log 11 divided by log 4 and get a decimal equivalent.
I mean, this be you. You think if I told like one of the guidance counselors that like log like
That's 8 or no?
That's 9. 7 to the 9x equals 15. Oh my goodness. So I can't manipulate the bases. That's always my first goal if I can. Just try to manipulate the bases. I can't manipulate the bases here, so it's isolated, yes? This one's got a little extra step in there. So Banks, tell us, log what? You were fixing to say it. What's the base?
Well, I was just gonna say log, because I knew you had to do that.
Oh, yes, you have to do that. What's the base?
9.
Of, well, it's going to be 15 because the log always, will somebody pick that up, please? Always equals
David, come on.
the exponent. Ah, I forgot to hit record on this.
wait, it's already isolated?
It's already isolated because it's by itself. The log is on a side by itself.
But no, it's not 5x and 1.
Sure it is, but that's part of the log. That is,
right.
okay, see the parentheses there? All right, so because I don't know how to get x by itself since it's hooked inside that log, what I'm going to do, or why don't you guess what I'm going to do? Change the form. and then I'm just going to solve. These are easy solves. I hope you find. 2 logs is a little bit harder. Looking here, whenever I change forms, what does it become? 4. What's the exponent? 3 equals. Can you solve that?
I don't.
I certainly hope so. That's a linear equation.
How did you get that?
Change the form. So before we were changing from guys, before we were changing from exponential to log, now we're changing from log to exponential. Remember whenever I introduced this, I said you have got to be able to fluidly move from one form to the other.
Yeah, I'll try. Can you like work just this one out real fast?
Log base b of a equals x is the same thing as b to the x equals a. All right, so now as I work this, 4 to the third is
64.
add 1. Notice that moves so incredibly slow. 65 equals 5x, and whenever I divide by 5, I get 13. Easy?
Kind of.
Wait, I want to look at it real quick.
All right, look at it for a second. Guys, 5.2 times the log base 4 of 2x equals 16. Can I change forms the way it is now?
No, the log's not
No.
isolated.
The log is not isolated. Okay, so to isolate it, what do I need to do?
Divide by 5.
Divide by 5.2. Someone with a calculator.
That's good.
What? Yes. Why would I make it what?
Why would you make it?
Eyebrows.
You could if you wanted to. That's a condensing trick, and you could definitely do that. No. If I ask you to condense, yes. Here, all it's going to do, it's going to cause me some trouble whenever I go to finally solve. I'll have x raised to a power still. 3.08. Now what? Change forms. What's the base?
4.
What's the exponent?
3.08.
What's it equal? What's 4 to the 3.08? What is it? 71.5. So now divide that by 2.
35.7.
Ben, don't guess.
No, that's right.
Is that right?
Ooh, you know me, I'm Major Ray Hunter, Mr. B.
What?
Decimals.
All right.
Decimals don't matter in
Easy enough? All right, let's look at the scenario with 2 logs.
I would nice watch that.
Or no, I had an old bracelet and then I got this one. Because the other one.
All right, if you have 2 logs and nothing else, only 2 logs, that's it. Okay? As long as they have the same base, and ours are going to have the same base for right now. So, for example, let's say I have log of 12x minus 1 equals log of 3x plus 13. Because there's nothing else, there's nothing added to the end over here, there's not another number, there's just 2 logs, and because both of these logs have the same base,
That equals to each other.
Yeah, yeah.
Oh, I thought that was wrong because you didn't say it.
no, it was absolutely right. It's that easy, and I'm not going to expand on that anymore because it is literally that easy.
Clutch, so the
Okay.
1 is harder than 2.
So if the logs are the same, it's almost exactly like the bases being the same for the exponents, we just set those exponents equal. So here we're just going to set that equal and solve, okay? What I do want to talk about is if there's something else in there, and I can go ahead, 9x equals 14. That's an easy solve there for you. Okay.
Yeah, I have an idea.
Okay, Ben, I got 7 minutes to get through this.
These teachers these days, they make them.
Oh, thank you. I'm going to say with more. So, for instance, maybe I have natural log of x plus 3, and I'm trying to use examples from your homework. Y'all always say your homework doesn't look like what we do in class. I can't get those by themselves, one on either side, and let them cancel, because there's that pesky 1 on the other side. Do you see that?
Mm-hmm.
But if you put the logs on the same side together, combine them how?
Like condense.
You're absolutely right. We can condense the logs. In other words, here, how would you condense that? If it tells you to add, what does that mean you're doing? Multiplying. So natural log, this is actually going to be x plus 3 times x, and all of this is going with the log.
Wait, so you can't cancel those out?
No, you can't cancel those out. Has to be on either side of the equal sign to cancel them out with nothing else there.
That's not
Yeah.
hard. Wait, so why don't you multiply the x to the other stuff? Maybe like
Why don't you? You can't do that because the addition in the middle tells us to multiply, not add.
So x
Wait, Miss
squared.
McGee, why don't
plus
you
3x.
multiply the x? Oh, you about to do that.
Now I have, y'all aren't going to like this one, I'm going to tell you. Now I have a log with only one log in it. The log is isolated. What do?
Change the form.
Change the form. I don't see a base here. What does that mean?
That was E.
It's e. This one's natural log. So the form, whenever I change it, is e to the what power? Equals. Y'all really aren't going to like this. I have a quadratic. I need to make it equal 0.
E equals 0.
Wait.
So I have to move that e.
Oh, wait, how? Okay, whoa. How did you just do that?
Maddie's useless fixing to happen. What?
How did you just go from ln to x2 plus?
I changed the forms. Natural log is the same thing as log base e.
Where'd the log go then?
I changed the form to exponential, from logarithmic to exponential.
It's natural log.
Correct.
Don't tell me, do we put it in the square? Do we do that?
That would be nice if that worked.
Do we put it in the square?
Oh no! I don't know how to do that.
That's a button on your calculator.
We put it in the
though.
quadratic formula?
Yes.
No.
So Anna, when she looked at it, said, "Oh my gosh, do we have to put this in the box?"
I'd rather
To
put it
which
in the box than put it in the
Tyshawn said,
formula.
"No, we got to do the quadratic formula." That won't box as nice as that would be. That would be nice if we could factor it, set each piece to 0, and solve. But unfortunately, there are not two numbers that multiply to e and add to 3. So my only other option, and I do apologize for choosing this example as the first
Wait.
example. I didn't know it was going to be this
There's
quite this tough.
one more
It's like,
thing that you could do.
Yeah, this was from your homework.
so on the test, are you gonna give us one of the tests?
It's I don't think it's that hard.
I
It's
mean, but
just
it's just a lot.
involved. It is a lot.
I'm
All
gonna
right.
mess up at some point though with that long of a
Let me
problem.
just set up the quadratic formula for you so you see what happens with the e, and then I'll give you your homework.
Opposite B.
Opposite b. I hope you all remember the quadratic formula from your
Or
cute little
A,
videos you
C.
did. And if you didn't do them from the ones you watched,
Oh yeah.
b squared minus 4 times a. C is actually negative e over 2a.
What is E again?
2.71. You can literally put 9 plus 4e on your calculator and get a decimal equivalent for it.
So you can put,
Yep.